Hello and welcome to this new video tutorial on how to use the Digi5 MXM30 demo version. In this case I already downloaded the software from the site and I saved it here in this folder. Just make right click on it and select extract here. All files will be extracted. If you want to know how to install the software, just open the README file. Anyway, the first thing you need to install is the MySQL connector. Right now I already installed it in my computer, so I won't do it again. This file here is only needed if the main installation does not install the compact server. So if you get an error, you can always come back here and install it. So we click on Setup and then we click Next, Next and Next. And that's it, the software is installed. Let's go now search for the software. As this is your first session, you will get a message that the software is only available for 30 days. You click on OK and you will see that some options are not available here, like data acquisition and some capturing buttons. If you want to change the language, you just click here in Preferences, then Language, and you select your language. So, inside the software, you will see that there is already an example folder where we can see some analysis already done. For example, here in Tendency, you can see the tendency on each point, on each axis. See the octave bands, another kind. You can open the files from here or directly from the trend line. You can open all files, you can analyze them, make zoom. You can use the tools from this button to measure side bands, for example. Another tool like markers, locate, to locate frequencies. You can also see the advanced tools, for example, to add channel analysis like bode. In this case, this analysis was made with two channels and they were saved here, once in the horizontal position and the other one from the optical sensor in the vertical position. In this case, we will open both signals in the same tab. To do that, you open the first signal, then you click on the Add button and you select to add from the database. Select the second channel and it will be opened as a second channel in the same tab. With this button here you will test the bode analysis. You can see this is the maximum amplitude. You can see also the phase here. If I bring this cursor here, phase changes 180 degrees. Here I can see all the graphs that can be plotted in this chart. To this same file we can also make a waterfall analysis and see it in a 3D graph. You can rotate it and let's increase the resolution. You can also change the window. The flap top window is very useful for this graph because it uses an algorithm that gives a very accurate amplitude so we can get a better view. Another thing you can try is to open the rundown orbit. This is an orbit recorded during a rundown analysis. We will open the horizontal file first and then the vertical one. Now we make the orbit. This is a rundown orbit, that's why it looks so. You just select the segment, you click play, and you will see how the orbit changes along the time. You will see that near to the second 14 we get a maximum amplitude. We will verify this in the file, and yeah, you see near to the second 13 and 14 is where you have the maximum amplitude. This is an horizontal critical frequency. Remember, the blue line is the horizontal and the green one is the vertical. You can also see the bump test, which is a recording taken exclusively for this example. Select the bump and verify the frequency. You can add a marker with the exact frequency with the locate function. This bump test was made on a fan and we analyzed its natural frequency. You can also see the ODS, the 3D vibration analysis taken to many of these machines. For example, let's see this interesting study that we did on this table. This example was only made for this tutorial and there is also a video for it. In this case, we will select only one frequency, the one from its RPM. The motor was put on the top of a table, as you will see right now. It is a little motor that I put on the table and we took a very simple root analysis. If we click on play, you will see how the motor moves and it deforms a table. You can increase the amplitude here just to exaggerate the movement. If you wanted to remove the movement of the motor so it doesn't interfere with the view of the table, you can do it. You increase 10 times and you will see how the table moves. Look how interesting this movement is. Now, this motor has a second vibration frequency at 7200 CPM, which is electrical noise. Let's select this frequency and see how the table moves at this particular frequency. Now the displacement is lower, so we need to increase the amplitude. We will remove again the vibration in the motor. Now take a look to the table and how it moves in high frequency. This is very interesting. This analysis was made with a simple root. You can also see the ODS analysis from this fan, which was made before and after it was balanced. You can see how it was before balancing, and now we are going to see after balancing. This is before and this is after the balancing. You can increase 10 times and see, this is a great balancing. You can also see here how to make a new balancing. Of course, you need an interface to do it, but you can take a look at the tools. This particular one is for balancing machines. You can select the type of your rotor and you need to put the dimensions on it. In this type of balancing, the software will give you the correction masses without putting any trial mass. There is another tool which is for in situ balancing, and it will use the influence coefficient method. In this case, you will have this balancing calculator for a single plane, 2 planes, and many other formulas for combining masses, adding blades to the fan, and so on. With this button here, you can see a short demo list of the bearings table inside the system. You can also try opening a root with the barcode reader. You just click here and the camera will try to read the code bar and open the root automatically. Here you will record each point until finishing the root. Once finished, all files will be saved in the database. Another option is to make right-click here and open a route manually. You can see more functions here like cross-power spectrum, frequency response function, etc. You can even open a file like this one and click play to hear as if it was an electronic stethoscope to hear the bearings of this machine. Well, this is all for now. Thank you for watching.